Section 9.5. Okay. 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 Section 9.5. Linear differential equations. So, yesterday you'll recall that we talked about separable differential equations. We talked about equations that were that we could separate all of the y stuff together and all the x stuff together to be able to integrate both sides and then solve the differential equation. Whether that's for y or just as some implicit equation, it doesn't matter. Right? But now we're going to encounter another sort of differential equation that we actually will be able to solve, which are called linear differential equations. Okay. Now, these equations have a general form, and that general form looks like this. Variables they use, they use dy over dx plus p of x, so some function of x times y equals p of x. Okay, cool. Does anyone have any guesses as to why this equation right here is called a linear differential equation? If you don't know, it's okay. I'm just curious. Anybody? Yeah. You just have y to the first power. Okay. And also your derivative should also be to the first power. But most equations should hopefully become like that. Most systems aren't, you don't typically make them squared, in the first place. It's just, it doesn't happen like that. So the big thing here is that this y is to the first power. Okay, so this is kind of the separator of this sort of equation. Now, it's possible that some of the separable equations that we did were linear equations, but not all of them were like that. And in this case, this may not always be a separable equation, right? So just case in point real fast, let me illustrate this equation. 2x. Okay, so this is doesn't look like a linear differential equation at first, right? And it's just because that dy over dx term is something multiplying by it. So let me go ahead and simplify this first. I'm going to take both sides and divide it by x, which is going to give me y prime plus 1 over x times y equals 2. Okay. So here's the question. Can I take this equation that I have here and separate it? Can I separate the x and the y from each other? And don't just say no, because, why would we be talking about it? Let's say, try to think about, so let's think about, right, if I take the 1 over x, y and move it over, I get 2 minus 1 over x, y, right? So the issue here, right, is that even if I try to get a common denominator here, what happens is the y is only on this term, right? The y thing's only on this term, so I cannot properly factor it out to get it by itself, right? They're kind of mixed in a way to where, I just can't really do anything, right? I can't separate it, so I can't solve it the way I would normally expect it to, right? But that's actually okay in this case because of how the left side of our equation is set up, which is I'll go back to here, which is x y prime plus y. Okay, now let's think about this. So we have, and maybe I'll write it in a form that you might be able to recognize what's happening. We have x y prime plus 1 okay. Right, so I have y here and its derivative, and I have x here and its derivative. Does this look familiar to us in any way? Right? Where I take one function multiplied by the other derivative, and then I add the derivative of the other function times, what is it? It's product rule, right? This expression is the derivative of x times y. Okay? Do we see that? If I take the derivative of x times y, I get this thing up here, which is cool, right? So what we have right now is that the derivative of x times y, which is this thing, is equal to 2x. So we might actually be able to work with this, because now I can take this dx and multiply to both sides, and I get the derivative of x times y equals 2x dx. Right? Now, if I integrate this left side, I'm saying the integral of the derivative of x times y. What is the integral of the derivative of x times y? It's literally just x times y. What's the integral of 2x? Oh, no. X squared, okay. And we have a plus 2, of course, just like last time. Can I solve this for y? Absolutely. I just take both sides, divide it by x, and we would get y equals x plus, and then, so x squared over x is just x, c over x. So that's our function. Okay? Good. So, right, what we noticed is that that left side was our product rule, and so we could kind of suck it back up from where it came from, right? And that allowed us to simplify this expression down to a form like, right? If I was given the equation in this form, right, you know, the idea might be, right, if I was given this, that, oh, well, if I multiply x on both sides, it would get me to this, which is the product rule, right, which is product rule that I recognize, okay? And that is going to be the general idea of this section, right? The truth is that every linear differential equation can be done in this form, in this way. Now, obviously, it's not always multiplying by x, but it's going to be multiplied by some function, okay? And that function here. That function is what we're going to call I of x. Okay? This function, right? So again, like I was saying, if we wanted to solve this equation given in this form, I'd have to multiply it by x first, right? And then it would work out with the product rule and everything. So the idea here is if I have a linear equation, is there some function that I can multiply by to get the same result? And there is, which is going to be this I of x here we're going to find. Okay. Well, what should end up happening, right? So let's say this I of x gives us what we want, right? So I'm going to take my equation, right? Maybe I'll just, to save us time, I'll write y prime instead of qx. Okay. What should happen is if I take this I of x and multiply it to both sides of the equation. What's going to happen is I'm going to get I of x times y prime plus I of x times p of x times y equals I of x times q of x. Okay, good. Now, if this is the right pick, right, what should happen, right, we have I of x times y prime plus I of x times p of x times y. This thing right here should be I prime of x. This should be the derivative of I, right? Because if that's the derivative of I, then it gives us the product rule, right? So we need to make that right pick, which again, I'll show you how to find what that pick is. That's going to give us this, right? But it should end up making this I prime of x. So then if I have ix times y prime plus I prime of x times y, this is a product rule, so this whole side becomes I of x times y prime. So like the derivative of I of x times y. And this is going to be equal to I of x times x, right? Or maybe just for the sake of, so whatever, it's the same thing, maybe I'll do d of x here, d over dx. Multiply the dx up. I get d of ix y equals I of x d of x dx, and then integrate both sides, right? Just like in the one over there, what should this turn into? What is the derivative of I of x times y? What is the integral of the derivative of I of x times y? It's just itself. And then this is going to be whatever this integral is, which it really depends, right? If you know how complicated the function might be. So then I can easily solve this for y, which is going to give me y equals the integral of I of x u of x dx over I of x. Right? I just divide I of x, and that's going to be my answer. Okay? That's exactly what we did over here. Of course, it was more of a grounded example instead of just like kind of the abstract functions, right? But this is exactly what we want to happen. So we can find a function that's going to do this for us, right? Now the question is, of course, how do I pick it? So the way we're going to figure that out is, let's see, maybe I'll. Okay. Remind me from earlier. I need I of x times p of x to be equal to what? I prime of x. Okay. Good. So I'm going to take both sides of this equation and I'm going to divide by I of x, which is going to leave me with p of x equals I prime of x over I of x. Okay. Now, of course, you can kind of worry about, ti over tx, or you want to think about that, how to integrate this. What I'm going to do is I'm just going to, there's going to be a dx that's going to get multiplied to both sides, so I'm going to go ahead and add that. Right? And so I get this expression, still the same thing. But now in this form, I can integrate this. Okay. Do I know how to integrate this guy? If I have I prime of x over I of x. Yeah, so we can do a U sub, right? I'm gonna let, where I just let U be I of x, and du be I prime of x, dx, right? So it's just a derivative, right? So we're gonna get on this left side. This left side, we're gonna get the integral of p of x dx, and we want this to be equal to the integral of du over u. What's the integral of du over u? Good. So we're going to get the integral of p of x dx to the natural log of technically the absolute value of u. In this case, we won't worry about the plus c here. I can just assume maybe that'll be absorbed into this guy. Ultimately, you could get a plus c here in some way, but you only need to do one pick for I. You don't need to go from its end, because it does give you an infinite amount of options from here. But we're going to go with the most basic, which is just there's no constant here. So I get the integral of p of x dx equals the natural log of u, right? Which is the natural log of, what is it? Absolute value of what function? I of x, right? That was our u. Okay. So how do I solve this for I of x? What is it? Yeah, just raise both sides to the e, right? Or make e the base of both. So that's going to leave us with I of x equals e to the integral of p of x dx. And this is called the integrating. Okay, this is going to be very important. If you don't remember anything else, what just happened here, remember this at least. Okay, I of x is e to the integral of p of x dx. So this is called my integrating factor. Right? This integrating factor is exactly the pick I need to make in order to make my linear equation sort out the way it's supposed to. Okay? And if you don't believe me, let's just bring back the example from a bit ago again, right? So, right, the equation was, right, so again, let's assume that instead of being given it being given in the form xy prime plus y equals 2x, let's say I was given this. Same thing, but x is defined. Okay. So if I wanted to solve this problem, right, I would have to say, okay, well, what's my p of x going to be? I need to see what my p of x is in this case, right? So what is p of x in this particular problem? Right? I erased the general form, right? Maybe I'll write it again here for you if you need it. What is p of x here? 1 over x. Okay, so in order to, this is linear, so I have an integrating factor. In order to find this integrating factor, I am told to take e to the power of the integral of p of x. But p of x is 1 over x. Okay. So what is the integral of 1 over x dx? Good. So we're left with e to the natural log of x. Can I simplify that? It's just x, right? Technically, it should be an absolute x. There it is. If I just take this equation and multiply both sides by x, that comes up here, and then I see the product rule that's supposed to happen, right? So this, if I didn't know to do this originally, this integrating factor would tell me to do that. Okay? We're gonna do some examples. That's just gonna be the rest of the section. So, is the structure seen there? Do we kind of know what's happening? Again, maybe it'll become clear once we do more examples, but there's it. Okay, good. So let's solve some differential equations. Okay, so I'll do the book problems again. Seems to be a good place to go for these. So we're gonna do number 6 from the book, which gives us the differential equation y prime minus y equals e. Okay, so this is the equation we're solving. Okay. Is this a separable equation? Can I separate this? Right, and by separate it, I can't, obviously there's just the y pieces over here, but there's still the dx. But then it's y prime, maybe it's easier to write it as dy over dx. But then that dx is going to cause issues, so it's not really separated in this case. They would have to be dividing or multiplying for it to. Okay, so this is not separable. And so since it's not separable, I can use is it linear? Why? Why is it linear? Why to the first power? Okay. Okay. The first section here in these exercises is to determine whether the differential equation is linear. Okay, so that's the most basic thing. Y has to be the first power. Yes. So only y has to be the first power. Y prime should be by p to the first power as well. But yes, anything else besides the y prime and y can be whatever. Y prime and y have to be to the first power. Okay. Mainly the thing is just that y has to be to the first power because otherwise you really can solve them. So that's kind of the key thing. Okay. So this is linear. Okay. So since this is linear, I need to find an integrating factor. Okay. Because I don't know if it's in the form I want it yet. So let's see if we can find the integrating factor. So integrating factor, right? I of x is going to be e to the integral of p of x. What is the integral of p? What is p? I guess what is p of x first? It's -1. So we get e to the integral of -1 dx. What is the integral of -1 dx? -x. And then don't worry about a plus in that case, of course. Just pick the simple assumption, which is just a constant being 0. Okay? But we get e to the -x. Okay? So this is our integrating factor. Right? So I'm going to take my equation and multiply both sides by e to the -x. Okay, that's my integrating factor, so I'm going to take that and multiply to both sides. Okay, so on the left side, I'm going to get e to the -x times y prime minus e to the -x times y equals, now let's talk about this right side. What is e to the -x times e to the x? It's going to be 1, right? There's a lot of ways to think about it. The simplest one I see here is just to take -x plus x, which gives you 0. So we get e to the 0, which just gives us. Okay, good. From here, right, is this left side in the product rule? Does it look like a product rule here? Yes, because we have, so if I let this be f, right, then I get g prime, and then this is f prime, right, because you have negative e to the -x, which is the derivative, times g, right? Most of the time, as long as you did your integrating factor right, it should be correct, but it might be a good thing to verify that everything works out right. Right, it should have that form. So, since this is the product rule, right, then I can just take this left side and rewrite it as, and I like to put the over dx, of e to the minus x times y, right? You just kind of take the two functions. So the first function is e to the minus x, and the second one's going to be y, right? In general, we saw, which I forgot now, but it was p of I of x times y. So that's what we get. Okay. I want this to equal 1. So maybe I'll multiply the dx up. So I get d of e to the minus x y x. Okay. What do I do at this point? Integrate both sides. What's the integral of the left side? E to the separation. Yeah, e to the minus x y or y over e to the negative a, it doesn't matter. Y over e to the x. What's the integral of the right side? Okay. And we're gonna have we'll put the plus c here, because our choice it does matter in this case, right? If you decide to include the random constant here, it would just make the problem a little bit more complicated, but you do definitely need it. Okay, so what's my last step? Solve for y. So how do I solve for y? Good. Divide by e to the negative x. Maybe I'll say, just to make it a little simpler, I'm going to multiply by e to the x, because that'll just cancel out e to the minus x. So we're going to get y equals x times e to the x plus c. Or you could write like x plus c times e to the x. That's our final answer. Okay? So that's all the differential equation for us. And if we were to check this, right, so I'll just kind of, yeah, so the derivative of x e to the x is just going to be x times e to the x plus 1 times e to the x. And then this guy always stays the same. But then the y will subtract off these two parts, which will just leave the e to the x. So this is the first. Any questions on that? No? Makes sense? Good. Okay. Let's do another one.
Why does this C not absorb the E to the X?
What is it?
Why does this C not absorb the E to the X?
Well, because it would absorb it if it was just e by itself, but since it's e to the x power, I have to leave it, right? That c isn't to the x power, so I can't. If it was just a constant, then it would absorb, but it's e to the x power. Okay, cool. Next example, let's see. Let's do. Yeah, like number. Okay, this is number 10 in the book. Number 10 is 2x y prime plus y equals 2 squared. Okay, so this is our equation. Okay. Is this in the form I need it to be in? No. Why not? What's the issue? Yeah, exactly. We have this 2x here, so I need to move that off of the y prime. So my first step is to take both sides of this equation and divided by 2x. Okay, which will just give me y prime. What am I going to have in this spot? 1/2x times y equals, and then what's going to happen? This is whatever, our root is 1/√x. Good. Okay. Now we can do our steps of finding the integrating factor and solving this. Okay. So let's do that. Let's see. Let's take. Right. So we need to find I of x. E for the integral p of x dx. What's the integral of p of x dx? Or sorry, what is p of x first? Yeah. Okay. 1/2x. What's the integral of 1/2x? 1/2 ln x. Good. That 1/2 is just a constant, so I can bring it out, and then I just left 1/x, which is just and x to the first power becomes natural, not square root, not x squared, not x cubed. Okay, so we get this. Is there any way that I can simplify this? Yeah, absolutely. So I could take this 1/2 inside my natural log. So I get e to the natural log of the square root of x, which can cancel out. Or I could also just take this and rewrite it as e to the natural log of x to the 1/2 power, right? Just remember when I have two exponents multiplying, I could just kind of pull one out for the moment. And then nat e to the natural log of x is x to the 1/2, which is also. So either way is fine, doesn't matter. But if you have e and you have natural log of x, those should cancel each other, right? Okay. So square root of x is our integrating factor, right? So I'm going to take my equation and multiply both sides by square root of x. Okay, good. So I get on the left side, I get square root of x times y prime plus, what am I going to get here in this spot? Good. And y, we're still, and this is going to be equal to, what do I get on the right side? 1. Okay. This is product rule. It's good, right? The derivative of the square root of x is 1/2 square root of x, and derivative of y is y prime. So then this left side is going to be, and maybe I'll go and multiply the dx as well, just to save some time. I'm going to get d of square root of x times y equals dx. Okay, 1 times dx. Okay. Integrate both sides. What's the left side turn into? X square root of x times y, right? Literally, you just take off the integral and the d. It's just whatever's on the inside. And then what's the integral of dx? 1 times dx, I guess. X plus c. Okay. So then someone will tell me what's my final answer going to be when I divide the square root of x on both sides. Good. Yeah, that's all the way up. Good. So that'll be my answer. Okay. This is the general solution to that differential equation. Okay. So again, big key here is is the integrating factor. Okay. Get the integrating factor. Should be a product rule. simplify it. Okay. Questions for me? Anything? No. Seeing what I want. Maybe we'll make. Okay, let's do. Let's do. Okay. We're gonna do number 8. Okay, so we've done 2 where you just have to find the solution, right? But now we're gonna get into initial value problem territory. Okay, where we have a value to add into the problem, but it still holds the same, like we still did the same thing. Okay, so maybe while I'm racing here, a comment I want to make. On the test, it was problem number 12. Many of you seem to be a little confused on what you were supposed to do there, right? If I have an equation and I give you the solution to that equation, I just want you to plug in the thing and show that both sides are true, right? Like if I gave you, right, let's see. So if I gave you this equation, right, and I said, okay, show that x equals 1 is the solution to this equation, right? You would just take x equals 1 and plug it in. I would say, okay, well, 2 plus 1 is 3, and 3 times 1 is 3. Great, fantastic, okay? That's exactly what I was asking for on that problem. I just wanted you to plug it in and show that both sides would give you the same thing, right? There was a lot of like manipulation to find what y prime was by plugging into the equation, and there was a lot of like saying not putting in y, even though I gave what y was. I had a few people say this is y, and I'm like, okay, great, I gave you the beginning. You really didn't do very much. I appreciate it though, I guess. So all you were supposed to do is just plug into both sides, right? Now, of course, there's the added aspect of, you know, I need to find the derivative of the thing, right? And then plug that in as well, but it's the same idea still holds. I just wanted you to show that both sides are the same thing. And then when it came to the initial value, which is why I thought about this in the first place, right? I gave like y of 1 equals e squared. All you needed to do is take that y function I gave you and plug in 1 and see if it gave you e squared. And since it was a square root of x times e to the 2x, if I plug 1 into that, I get e squared, right? So that was it. That was all that part was used for. That did not factor into plugging into the equation at all. Okay? So just for the future, remember that. Oh, maybe that was my fault that I didn't clarify exactly what I wanted, but yeah, maybe I'll, if I do examples in class, I'll try to make sure to highlight a little more. Like, this is what's going on. This is what I want you to do for this sort of problem. So, good. We'll bring back on the orange again. Anyway, number 18. Okay, number 18 says to solve the initial value problem, and the initial value problem we're given is x y prime plus y equals x okay, so we get this, and then the initial value we're given is y of 1. Okay, so again, to elaborate, the purpose of the initial value is so I don't just have an ambiguous c, that I have some particular value that is that c, so I know what the exact solution is. I don't want just the general solution, I want the one that passes through this particular. Okay, good. So number 18, right? I want to solve this, right? So I want to get it in the form of a linear equation, all right? If you wanted to try to separate it, you could. That's not going to work very well, but go ahead and give it a try. Why not? But this is definitely a linear equation, but it's not quite in the form I want, right? So what is my first step here? Yeah, so we want to separate out the x. We want to get rid of the divide the x. I need to take both sides and divide by x. Which is going to leave me with what? Good. So we have this. Now, so I need to figure out what the integrating factor is now, right? So I'm going to take I of x is e to the integral of p of x, x. What's p of x? Okay, which is going to be e to what's 1 over x dx? So we just go left with x. It's natural log of x and e to yes.
X and y variables being I of x never because zero.
I mean, it'll always be the same in this problem. The I of x won't be the same for all problems. You always find them the same way, but they're not always going to be x, for example. They might, like we had e to the minus x earlier, right? It depends. You find them the same way though. They're always set up the same way. Yes, that's correct. Okay, so I get x, okay, which is kind of funny because so we're multiplying by x, right? Notice what we did at the beginning was we divided by x, right? So we just wasted a step, but it's good to make sure we're doing this correctly, right? So I was looking through trying really hard to get one where it would be valuable for us to divide, but it looks like I found another one where it's just take how it is anyway. But I would still think this is more valuable to do instead of like saying, oh, does it work first? And you think about it, you can always guarantee you find it. Okay. So I'm going to take x and multiply both by both sides, right? So we go right over here. So we're going to have x times y prime plus 1 over xy equals x times natural log of x, which is just going to give us the equation we had earlier. But is good to verify, right? So we get this. Okay. What is this side going to turn into? This left side. Yeah, so we d over dx of what's on the inside? Xy equals x times natural log of x, which again I might go ahead and move the dx over. Okay, and then what's our next step from here? Just integrate. Good. Okay. Okay. What's the left side? How do I do the right side? Right. We use integration by parts, right? I can't just integrate x and integrate natural log of x, right? I have to use integration by parts. So if I use integration by parts here, so maybe I'll do it in a little box up here. Maybe I'll do this. So we're integrating x ln x dx. So what should my u be in this case? Good. Good pick. Yep. dv. Okay, so what is du? X, and what is v? Oh, sorry. This is dx. What's v? Yeah. I'll write it as 1 half x squared, but it doesn't matter. So you get 1 half x squared, right? Okay, so this is going to be u times v. So natural log of x times 1 half x squared minus the integral of what's going to be on the inside of the integral here. So 1/2 x squared du times 1 over x dx. But one of the x's is going to cancel out. So we're going to get x to the first power here. And what is the integral of 1/2 x dx? So again, the 1/2 can just come out, which is constant, right? What's the integral of x dx? We already did it, right? Just 1/2 x squared, right? I'm just doing, again, I can just bring this 1/2 out, and then I'm just doing x dx again. We already did, it's 1/2 x squared. So we're gonna get 1/2 x squared times 1/2. So we get minus 1/4 x plus a. Okay? So then how do I solve for y? So we're left with y equals, my final answer right here. Or at least the final answer for now. Obviously, there might be something else we have to do after this, but what's the final answer?
X times
Fantastic. So this is the general solution. So am I done? No, because we were given a value plug in, right? So maybe so we don't have to go over there for now. I'll just take this up here. So I know that y of 1 is 0. Okay. So where does this 1 go in for? Is that the y or is that x? That is x. Okay. Someone want to point out, because again, I saw that a couple times where they're putting this as y, putting this as x. Okay. This is x and this is y. So 1 goes in for the x value. Okay. And then where does 0 go in for? Y. The y. Okay. So we're going to get, so when I plug in, so when I do y of 1 is 0, that's going to give me 0 equals 1/2 times 1 times the natural log of 1 minus 1/4 times 1 plus c over 1. Okay. What is the natural log of 1? 0. So this term just goes away. And then c over 1 is just c. So we're just left with 0 equals c minus 1 over 4, right? Because 1 over 4 times 1 is 1 over 4. So c is 1/4. Okay. So maybe I'll do a different color real fast. Just put in the big box as our final answer. Y is equal to 1/2 x times the natural log of x minus 1/4 x minus, or plus, sorry, because it's plus 1/4. All right, I put c over x, or I can write that as 1 over. If you're taking the test and you have time, maybe it would be a good idea to test it, see if it works. Okay. Any questions on that section? You good on that? Okay. That's all those problems are. Hopefully you can handle it and kind of work through it. That's all. Okay, cool. Go take a break. You have until the hand strikes the 8, which I guess is 4:40 in this case. Yeah, 4:40. Yeah, absolutely. Yep. Which one is this? Oh, it's part C. Okay. So you have So my first question is, I'm confused where the E is. I don't think that's what you did there is allowed, right? Because if I take the natural log, I have to take the natural log of E and would be this part, right? I can't just take the natural log of this part, right? The natural log of A times B is not just the same thing as the natural log of A times B, right? I have to do both parts. If anything, I can write this as the natural log of A plus natural log of B, but I'll say right now, that's not gonna be very advantageous. I would not go there. Okay, so I would not use the natural log, okay? Just separate it, and what you should have should be something that you can integrate both sides, okay? So, yeah, don't use, that's not gonna be real close. Yes. Well, we still need to, I need to solve for y, right? If there's a y prime some wrong, that's wrong. I can't have that, right? So in that case, so you did the right step in like this factor right now, right? So you have, let me see. Yeah, so you have y prime as well, right? So you're gonna have y prime times x squared plus 1 equals 2, which is x y squared plus x, right? So you can factor, right? Which was the specified factor. Now I want to take everything that has an x in it and put it on one side. And I want to take everything that has a y in it and put it on the other side. So I'm going to have y prime over, this is multiplying over here. So I'm going to divide it. And then this is, I want to move the x over here. So I have x, because I still the x here over x squared plus 1. Good. Yeah, absolutely. Good, good. No, this is great. So from here, yeah, this is good. Now you just integrate that. Yeah. So that's good. Yeah. So
But if you're at a restaurant, well, it depends what you buy. Like, shoes are more expensive, clothes are less expensive. Maybe not clothes, but food. Depends what you get, but most of the are less expensive.
not necessarily. I can't really do that. I mean, you would just bring it over here instead in a weird form. You want to do this. And then we actually should know how to do both of these. This one is just one that we have memorized, and then this is one
Well,
that.
okay, it's not cheap, but there's less fees.
Yeah, that's good. Yeah, no, absolutely. To the bonus question.